Okay, this is the activity 2 part of 4.4. So we're going to be working with volume. It's going to be very similar to what we just previously did in activity 1, but once again, just working a different form of geometry. So we're going to be going through and writing our equations to the conditions that are in the inequality. And then we're going to pick solutions. So we want to find 4 values or 4 solutions that we could use in that inequality to make it a true statement. So it says you want to find the values of x so that the volume of a rectangular prism is at least 50 cubic centimeters. So let's start with the back end of our equation. At least 50. So could it be 50? Yes, so it could be equal to 50. And if we want it to be at least 50, we would like it to be bigger than 50 or equal to 50. So it's going to look like this for our symbol. Okay, so based on that, I can eliminate that it can't be that equation because that one does not have the equal to in it. And at least means that it could be 50 or it could be more than 50. Okay, so now we have to review how you find the volume of a rectangular prism. Well, volume is going to be area of your base times your height, or with a rectangular prism, you're just multiplying all of your dimensions together. So the key thing on this is that third dimension there on the right side, that x plus 2 has 2 pieces to it. So we're going to go ahead and do our 5 times 3. And then we have to take that also times x plus 2. So we're going to do the 5 times 3, which would give us 15. And then times our x plus 2 yet. Okay, now that, once again, is not part of any of our 3 equations that are left over because we have to remember to distribute. So 15 times x would give us 15x. Okay, so that one's now eliminated. And then remember to take to your second number. That's the most common made mistake. 15 times 2 is going to give me plus a 30. So there's our equation, which would be this one right here. So we found our equation. Now we're going to pick some solutions for x. So I'm just looking at it and saying it can't be too big. It can't be like 5 because look at this distance compared to that. Okay, not always a true statement, but I'm going to start with numbers that are less than that. So I'm going to start with maybe, let's try putting 2 in there and just test it out. So I'm going to try starting out with putting 2 in for x. So 15 times 2 plus 30. So this would give me 30 plus 30 is going to give me 60. Is 60 greater than or equal to 50? Yes, so 2 would work. So solutions that we could use. We could use 2. Okay, so let's try 1 just to see. Okay, so when we substitute in a 1 in here, 15 times 1 is 15, plus 30 is going to give me 45. Is 45 greater than 50? No, so 1 will not work. So it can't be a number smaller than 2. It has to be numbers bigger than 2. So we could use 2, 3, 4, 5. You could even use decimal numbers that would fall in between there. Okay, so let's go ahead and move on to letter B then. Once again, working volume, I believe. Okay, so here's 2b. So once again, they want us to do volume. You want to find the value of x so that the volume of the rectangular prism is no more than 36. So we know it's going to have 36 in the back end. And we do not want it to be any more than. So could it be 36? Yes, it could be 36, but it can't be more than 36. We want it to be smaller than 36. So 36 has to be the biggest number or it has to be equal to 36. So it has to be that symbol, the less than or equal to symbol. So it can't be these two because those don't have the equal to part of it. So now we're at least down to a 50-50. Okay, so let's go through and get our equation. So we would normally multiply all these together. So I'm going to go ahead and multiply these two together first. So 4 times 4.5 is going to give me 18. So I still have 18 times 2x plus 1. Okay, because remember, you multiply all three together. So let's do our distribution. I get 18 times 2 is 36 with an x, and then 18 times 1 is plus 18. Okay, so here's our equation. And now we want to try and pick some numbers that we could use in place of x. Okay, so looking at that, just looking, it's 2 times something plus 1, and that looks like it's a little more than, I mean, like if I'm just comparing, this is 4, this is bigger than 4, but not a whole lot bigger. So I'm not going to go with 4 for that. Let's just try like 2. Let's try 2 and see where it gets us, because we're taking 2 times a number. So let's try substituting in 2 for x. So we're going to test 2. 36 times 2 plus 18. Okay, so if I do 36 times 2, that's going to give me 72. That is not less than, so that's way too big. 2 is way too big. If I put 1 in there, it's still way too big. Because if I put a 1 in there, 36 times 1 is 36 plus 18. That's still too big. So we're going to have to use numbers that are less than 1. Let's try a decimal number. How about 0.5? So let's try 36 times 0.5. And if you want to do a fraction, you can do a fraction. I'm going to do it as a decimal. Plus 18. Let's see what that gives us. So 36 times 0.5 is going to give me 18. Plus 18, that gives me 36. Is that less than or equal to 36? Yes, because it's actually equal to 36. So 0.5 is the biggest it can be. The biggest x can be. So solutions, well, 0.5 is the biggest. So then we have to do numbers that are smaller than 0.5. Because anything bigger is going to give me a number that's bigger than 36. Because we already tested whole numbers. So how about like 0.4, 0.3, and 0.2? And you could really use any decimal that's less than 0.5, and that would be a true statement. You could say 0.49 if you wanted to. Okay, so that's it for this part of the activity. Once again, it's just practicing using some geometry skills and then also using the skills that you are learning in 4.4. So good luck with this lesson.